So on x squared equals 81, the expression is already x and it's being squared, so it's already step 1 is in the right form. Step 2 says to take the square root of both sides. So I'm going to take the square root of both sides. And step 3 says on that very next step, put the plus or minus on the number side, okay? So what is the square root of x squared? Well, the square and the square root undo each other and you're just left with x. And what's the square root of 81? Well, that's 9. So my two solutions are 9 and negative 9. I've seen books write it this way, or you can write it plus or minus 9. I'm pretty lazy. I like to use a plus or minus so I don't have to write 9 out twice. Either way is fine by me. Now, on the next problem, notice that this x squared is not yet all by itself. Okay, the expression, or x in this case, has to be squared all by itself. So in order to get it all by itself, I'm going to add 23 to both sides, which gets me 9x squared equals 23. And x squared is closer to being by itself, but it still has that 9 in the way. So I'm going to divide both sides by 9 to get x squared equals 23/9. Now this expression squared is all by itself equals some number on the other side. So step 1 is now done because the x squared equals number is in the right form. Step 2 says to take the square root of both sides. So I'm going to take the square root of both sides. Notice that the square and the square root undo each other and all you're left with is x. Now, step 3 says when you take the square root of both sides, you must take the plus or minus part. So on this very next step, you must put the plus or minus part. Sometimes people do the problem and they work it out, and then at the end they try to slap on that plus or minus, and sometimes that doesn't work. So make sure you do it on the very next step. Alright, so I have to reduce this. I'm going to take the square root of 23 over the square root of 9. Now the square root of 9 is the problem because you can't have radicals on the bottom. But the square root of 9 is really easy. That's just plain 3. So I didn't even need to rationalize the denominator. All I had to do was reduce. So my answer could be plus or minus the square root of 23/3. Or if you prefer, you can write the square root of 23/3, comma, negative the square root of 23/3. Either way is fine. On our next problem, we have no linear term, right? There's no b term. The x squared is not yet quite by itself, so I have to get it by itself by moving the 4 out of the way. I'm going to add 4 to both sides. And then I'm going to divide both sides by 7. So this is now all by itself. This was a very good candidate for square root method because there was no linear term, there was no like plus, the bx term in the middle. Because there was no term there, it was pretty easy to put it in this form. Okay, so step 2 says take the square root of both sides. And whenever you take the square root of both sides, what must you put on the immediately next step? Plus or minus. Okay, so on the square and the square root undo each other and you're just left with x. That was the whole point of taking the square root, is to undo the square. And then we have the square root of 4 over the square root of 7. Now the square root of 4/7, I'm going to come over here, this 2 over the square root of 7. Now that's still a problem because you can't have the square root in the bottom, so I need to rationalize 2 over root 7. So I need to multiply it by something so that I have an even number of groups to come out. So I have 1/7. In order to get it out of the house, because this is a square root, I need 2 7s, which means I need one more copy of 7. So the 2 7s come out of the house and become plain 7. So I have x is equal to plus or minus. After I've rationalized the square root of 4/7, I'm getting 2 square roots of 7 over 7. And then I can write that plus or minus 2 square roots of 7 over 7. Or if you really wanted to, you could write it out, both of them. Now on these problems, I have more of an expression instead of just x. So I have x minus 1 quantity squared equals 25. Step 1 says to put it in the form expression squared equals number. Well, this certainly is. The expression is the x minus 1 quantity squared equals 25. That's the number. So step 1 is actually already done for us. Step 2 says to take the square root of both sides. Step 3 says every time you take the square root of both sides, you have to put the plus or minus part. So going back here, the square and the square root undo each other, and you're just left with x minus 1, the radicand, and then the square root of 25 is 5. To solve this, I'm going to add 1 to both sides, and that gets me x is equal to 1 plus or minus 5. Now, that looks like a fine answer, but I actually have to keep going on this one because 1 and 5 are both whole numbers. I actually know what 1 plus 5 is, and I know what 1 minus 5 is. So I want you to break those two up and add them. So I have 6 and negative 4, and those are my solutions, 6 and negative 4. We cannot leave it 1 plus or minus 5 because you know what 1 plus 5 is and you know what 1 minus 5 is. Because 25 came out to be a perfect square of 5, then you have to keep going. Now that's not going to be the case on the next two. So let's try the next one. Step 1. Is it in this form expression squared equals a number? Well, sure it is. This expression 3x plus 1 is squared and it equals some number. So step 2 says to take the square root of both sides. On step 3 it says take the plus or minus part on the immediately next step. So make sure you have that down. The square and the square root undo each other and you're just left with 3x plus 1. On the square root of negative 9, that becomes 3i. Now, on the first problem we had a positive square root of 25, which came out to plus or minus 5, no i's. But on this problem, because 9 was negative, we had to take the I part. So I'm going to solve for x by subtracting 1 from both sides. I get 3x equals, don't try to add those two, negative 1 plus or minus 3i. You can't combine a real number and an imaginary number. They just have to be next to each other in a complex number. And then I'm going to divide everything by 3. So my solution is x is equal to negative 1/3 plus or minus I. Notice that that is an a plus bi form. Now you could write both of them out. I'm just not going to write both of them out. I don't think that's necessary. On our third problem, we have this expression being squared, but we have these other things around it. So it's not quite all by itself, but it is an expression squared. So the plus 3 has to go, and then the multiply by 2 out in front has to go. So I'm going to take a couple steps to set it equal to just a number. So this gets me now 2 times 2x plus 1 squared equals 8. Notice my expression is still squared, but it's not quite by itself. So I'm going to come back and divide each side by 2. So now I have 2x plus 1 quantity squared equals 4. Now the expression is squared. Step 2 says once it's in the correct form, you're going to take the square root of both sides. Step 3 says you must put the plus or minus on the very next step. Now the square and the square root undo each other. That's why we took the square root of both sides to get 2x plus 1 from the radicand equals plus or minus the square root of 4. That's plain 2. So then I'm going to subtract 1 from both sides and I get 2x equals negative 1 plus or minus 2. Then I'm going to divide both sides by 2, and and I get x is equal to negative 1 plus or minus 2 over 2. Now, I have to keep going because I actually know what negative 1 plus 2 is. Earlier, I couldn't do negative 1 plus or minus 3i because I can't add a real number and an I, but I can add two real numbers in the numerator, so I'm going to have to keep going on this problem. So I have negative 1 plus 2 over 2 and negative 1 minus 2 over 2. So that gets me a half and negative 3 halves. So my two solutions are 1/2 and negative 3 halves.